Okay guys, today we are going to look at complex numbers. So first let's look at a general definition for complex numbers. So if you have the number a plus bi, it is said to be complex written in standard form, where it has both a real part and an imaginary part. So in order to understand that, we need to make sure we understand what an imaginary number is. So an imaginary number is that bi part of a plus bi. So if b is a number, let's say b is 4, 4i would be the imaginary number. We also are going to take a look at complex conjugates, which basically if you have a complex number, then its conjugate is, if it's a plus bi, then its conjugate is a minus bi. So let's get started into our actual notes. First, we're going to look at the imaginary unit I. So it is, by definition, I equals the root of -1, because there is no real number x that can be squared to produce a -1, which we should know all of that already. By definition, I squared equals -1. We say that the complex number a plus bi is written in standard form like we had previously mentioned. So if you're looking at b as a number, or excuse me, b as 0, not a number. If b is 0, then a is to be called the real number. And if b is a number other than 0, then it's the imaginary number. And if we have this complex number a plus bi equaling bi, then it is pure imaginary number. Also, this set of complex numbers consists of a set of real numbers and a set of imaginary numbers. So two complex numbers, a plus bi and c plus di, written in standard form, are equal to that of each other if and only if a equals c and b equals d. Okay, now let's get into some operations with complex numbers. So to add two complex numbers, basically you are just adding the real parts, and then you're going to add the imaginary parts, so they're separate. Same thing with subtracting. If you're subtracting, you're going to subtract the real parts and the imaginary parts separately from each other. Also, we have the additive identity and additive inverse, which basically says identity means that the complex number system is 0, and the additive inverse is if you multiply by a -1, it's just saying that you would distribute a -1 throughout that binomial. So basic properties that we use in regular expressions, we're going to be using with complex numbers and expressions. So now let's look at performing operations. So when you look at this problem, you have three parts to it. You have that b minus 6i, 3 minus 2i, and the 4i, and you're either performing addition or subtraction. Just remember with this minus sign here that it does need to get distributed, and it's only distributed to what is in parentheses. So if we take a look, I do need to scroll down a little bit. If we take a look and we start by distributing that negative turns the 2i into a plus, and then at this point you're combining all of your like terms. So 5 minus 3, and then -6i plus 2i plus 4i. You can kind of think of the I as like an X or like a variable in this type of a problem. It's combining the coefficients in front of the I. And it just so happens that the -6i plus 2i plus 4i does give you 0. So the answer to this simple operation problem would be 2. Okay, let's also now look at multiplying. So if you're multiplying, you do want to use your multiplication rule, basically using distributive property and FOIL. That's basically what this is all saying. So use distributive property to multiply the two complex numbers, similar to that of FOIL. So you would do your first, outer, inner, last. When you do that, if you are multiplying a BI times a DI, you are going to get to a point where you have an I squared. And recall from the first slide, or first part of your notes here, that I squared actually equals a -1. So that's going to have to come into play in our example. Okay, so now let's look at an example. We have these two binomials that we're multiplying, so we are literally just applying FOIL. So first would be 5 times 3, 5 times negative 2i, then negative 6i times 3, and negative 6i times negative 2i. So multiplied out, that's what, or FOILed out, that's what it would look like. So we have that 15 minus 10i minus 18i plus 12i squared. So at this point, again, like I had said before, you can kind of treat your i's as an x. So these two terms can be simplified to give you a negative 28i. When you get over here, we do get that I squared term. So I squared is really negative 1. So it's like saying 12 times negative 1. So it's then going to become 15 minus 28i minus 12. So our final answer here is to combine those real parts, and we get 3 minus 28i. Next, let's look at some complex conjugates. So the product of the conjugates is always going to be a real number. To write the quotient of a complex numbers, such as the a plus bi and the c plus di, we basically are multiplying the numerator and denominator by the complex conjugate of the denominator. I think that most of you have seen this already. I believe this is a part of Algebra 2, but we're going to just refresh before we go into more graphing with this stuff. So let's take a look at an example here. Sorry, I forgot to shade this. If we take a look at the example here, screen shade, we are dividing these two binomials. So the first part is to figure out what our conjugate is going to be. So we're taking our denominator, and our conjugate is just going to be the opposite sign here. So it's 2 minus I, so our conjugate is going to be 2 plus I. So we're going to multiply both the numerator and the denominator by that 2 plus I. Again, you're doing two binomials, multiplication, so you're just doing FOIL property. When you FOIL, you're left with these two, quadratics. And we do want to combine like terms. So when we combine like terms here, you're left with the 2 plus 3i minus 1, because remember that squared is a negative 1. And then last step is to just kind of simplify a little bit further, and you're going to be left with 1 plus 3i over 5. It can be separated into 1/5 plus 3/5 I as well. That's fine. Or you can leave it as that fraction there. Okay. Now let's just kind of look at the solutions to complex numbers. So if we have the principal square root of a negative number, let's say negative a, is defined as the square root of negative a equals the root of a I. We already, like I said, we've already kind of looked at this. We've seen this in a couple of problems already. So to avoid problems with square roots of negative numbers, be sure to convert complex numbers to standard form before multiplying. So if we take a look at this example here, again, I forgot the shade, sorry guys. If we take a look at this example here, if I want you to take 5 minus the root of negative 4 squared. We already have seen something like this. The root of negative 4, you all should know, is 2i. So we're going to change that to 5 minus 2i squared, quantity squared, before we actually do the multiplying here. Now remember, when you're squaring a binomial, this means that you are actually going to duplicate that binomial, multiply it by itself. So we're going to be left with doing 5 minus 2i times another 5 minus 2i. FOIL that out, and we are going to get 25 minus 10i minus 10i again, plus 4i squared. So again, we're going to combine our like terms in here. Negative 10i minus 10i is negative 20i. Over here we have that I squared, which equals negative 1. So we're going to do 4 times negative 1. So this is what we get here. And then one last step of simplifying will then give us 21 minus 20i. Okay, I know I went pretty quickly through all this, but basically I did so because this is a review. So hopefully you were able to catch all of the notes, and if you do need to go back and look over this again, please feel free to do so. And we're going to get to some practicing when we meet back together in class.